Hello, everyone. You are welcome to this discussion on image segmentation. In our last discussion, we talked about reviewing papers, and then when you look at the review, especially those who have submitted their assignment and that has to do with image processing or image segmentation. Let us take this intruder detection and look at what someone have presented here for us or to us. When you look at this intruder detection, like reference 1, and that first column, you have something like segment an image into useful regions. You could see that the author applied that. That's why the reviewer have said yes. And the second column, you will see perform measurement on certain areas. Yes or no? No. So, but tonight or today, we shall be talking about segmentation. Segmentation. So that's our major focus for today. That's our major focus for today. Segmentation. That is, how do you segment an image into different regions, and what are the benefits or what are the tasks associated with segmentation? So segmentation is one of the operations you commonly come across in machine vision related projects, segmentation. But before going further, let's understand what exactly we mean by segmentation. Is there anybody that can, looking at the meaning English-wise, what do you think? Segmentation. When you want to segment, what exactly do you have in mind? So that's what we are going to be discussing tonight. So I have a slide here that I'm going to be using for today's class, segmentation. So at the end of this class, you must have basic idea of and basic knowledge of what segmentation is all about. So let's start like this. Segmentation, or what is called image segmentation, is an operation, or is the operation of partitioning an image into a collection of connected sets of pixels. That is, you may segment image into region, and which may cover the whole of the area, or into linear structures, such as line or curve, or the third one has to do with 2D shapes, such as cycle, ellipse, and ribbon. What exactly do we mean? Look at this image now. You can see that we can segment them into different parts, into different regions. We have the area that is, we have the sky part that you can see. Even when you are looking at the sky, you may also segment it into different colors, and so that's what segment. So this is what you call region segmentation. Region segmentation. We also have what is called straight line segmentation. Straight line segmentation. Most of us will have been using this algorithm in some of our social media or image processing apps on our phone, especially after capturing images. There is also another type of segmentations, lines and circular arcs segmentation. So that's just what it's all about. So let's now go back to the definition itself. What is image segmentation? There are many definitions regarding image segmentation, but let's look at these three common ones. Number one, which was defined by Castellman. He said, image segmentation is the process of isolating objects of interest from the rest of the scene. I've mentioned this in one of our classes before. That's where you talk about foreground and background. Let's look at another definition, which has to do, which is from PAL. So the definition goes thus: image segmentation is the process of partitioning an image into non-intersecting region. I want you to take note of those words, non-intersecting region, such that each region is homogeneous. That is, they look alike or have a lot of things in common, and the union of no two adjacent regions is homogeneous. That's another definition. So again, when you are dividing an image into non-intersecting region, don't forget the picture I show us here. This is what you mean there. Segmentation. You are segmenting it out. Let's also look at this third definition. Image segmentation is to divide an image into parts that have a strong correlation with objects or area of the real world contained in the image. That's another definition of image segmentation. So you all understand what image segmentation is all about now. In brief, what we are saying is that segmentation is more or less subdividing an image into its constituent regions or objects. That's what segmentation is all about. So, again, when you subdivide an image into constituent regions, and then they are non-overlapping, we can say that is what image segmentation is all about. Don't forget, this is the flow chart from, you can have an input image, you perform image segmentation on the input image, then you have your object image. That object image, that's where you do your features extraction. And from your features vector, you can do classification in order to identify or recognize the object. Don't forget, there are some processes before reaching this stage. So image segmentation, you have the input image, you segment it, and then what the output of it is what you call object image. After you extract your features from them, then we have the feature vectors, and then you can perform your classification in order to identify the object. In general, we also have what is called autonomous segmentation. Autonomous means that on its own, without any input. That's the only one that is a bit difficult when you are performing image segmentation. So and autonomous segmentation is one of the most difficult tasks in image processing. It is difficult because of many reasons. Number one, you may have what is called uniform or non-uniform illumination. That is, one side of the image is looking brighter than the other side. Or when you have partial occlusion, that is, one side has so many, as it's looking bright in the image, while the other side is not looking bright. And then why autonomous segmentation is a bit tough also, you may not have control over the environment. And then inadequate model of the object of interest. Again, it may be as a result of noise. Don't forget, noise in an image is totally different from noise in music. They are totally different. So these are some of the reasons why image segmentation seems a bit tough. Now, we can divide segmentation approach into three. Number one, into three groups according to dominant vision they employ. You can have what is called segmentation based on global knowledge about an image, and then you can now use this one. You can use this knowledge in histogram, or you can use it, and then you can use the knowledge is usually represented by the histogram of image features, and then from there you do your segmentation, you do your classification. But in this case, we don't want to use classification, but segmentation. We also have edge-based, that is utilizing edge detection process to find a closed boundary so that inside and outside can be defined. That's another method. And then we have what is called the region-based. These techniques proceed by dividing the image into regions that exhibit similar properties. Don't forget what we have there as region-based. This is a typical region-based. That is, they have so you have regions with similar properties. And then this is what you have straight line. Segmentation, what we have here is lines and circular arc segmentation. So that's what we are talking about here, that region-based segmentation. That is, this technique proceeds by dividing the image into regions that exhibit similar properties. Okay, segmentation algorithms generally are based on two basic properties of intensity value. We have what is called discontinuity. Discontinuity simply means that there is an abrupt change in the intensity of the image. I will explain that to us. And then it can also be as a result of similarity. So let us take it one by one. So how do we use that one to detect points, line, and edges? Is by what we call discontinuity. So we have this one as part of what we call discontinuity. So this is another thing that may be of interest to us when we are talking about methods. The first one is thresholding. That is, how do we segment Biliki? Assuming, okay, let me ask Fatima. Fatima, how do we segment people in a course into two classes, pass or fail? We usually use 40% as that mark. Am I right? So that 40 is what we regard as the threshold value. So if you score above 40, then you come into that group that you call pass. But if someone scores below 40, then that person comes into another group that we call fail. That is one technique that we call thresholding. So the output of thresholding is usually a binary image. That value in that example I just mentioned is what we call the threshold value. Okay, this technique is particularly useful for saying which contain objects on a uniform contrasting background. So this is what we mean when we say thresholding. So that's one method. And then mathematically, this is what we mean when we talk about region segmentation. And then the mathematics is what we have on the screen. That is, we have the union, that is, segmentation is a partition of an image high into a set of region S, satisfying number one, the union of all the regions, and then you have the intersection, that is, no region intersect, and we have what is called homogeneity property and union of adjacent, and that's what we mention when we are doing region segmentation. So main method of region segmentation, number one, it can be region growing, it can be clustering, and it can be split and merge. So let me stop at this point and let me take your feedback on even the definition of what we call segmentation. Ask your question first before we move forward. Segmentation. If I'm to ask you that you are to discuss this in a layman term, what do you think you will say segmentation is all about? So I'm waiting for your feedback. What do you think is segmentation all about? Hope you have been seeing my slide before now.
Yes, sir.
Yes, sir.
Okay, what do you think segmentation is all about? So you can raise up your hand or you can type it. Segmentation is just simply dividing images into clusters. Segmentation is dividing what? Images into different regions. That is, you have an image and you are dividing them into regions that have similar properties. In a class of 20, you may want to divide them into males and females. In a class of 30, you may want to divide the performance, and you can now say those who score above 70 should be awarded an A grade, while those who score between 60 and 70 are awarded a B grade. So that's more or less segmenting the performance of an exam or quiz or test based on their performance. Based on their performance, that's another thing that you can say is segmentation. So we can also apply this one in machine vision, and that process is what we call segmentation process. So segmentation is the process of isolating objects, or the process of dividing an image into parts that have strong correlation, that those who are in the same cluster. Like I've said, in Nigeria now, for you to be in B grade, it means that you score between 60 and 69. So you have similar properties. That's what segmentation is all about. And then segmentation assists in understanding or identifying the image better. So those who are in the same cluster or region, we have similar properties. That's what segmentation is all about. And then we have looked at three types. Which is, you can do image segmentation based on region, or based on linear structures, and based on shape. Based on shape. That's what we have looked at under segmentation, and we look at all these examples. And we also look at this process flow. Number one, you have an input image. It may be a binary or grayscale image. Then once it comes in, you perform segmentation operation on the image. And what you have as the output is what you call object image. That object image is being fed into the feature extraction block. And from there, the output will be feature vector. That is, those information that you will use to identify that object. And then that feature vector is now fed into the classification algorithm or block before the object could be identified. So that is what you call image flow process. So how do we recognize? What are the basic properties that we look out for when we want to do image segmentation? And these two values, or these two processes, are based on what is called intensity value. Intensity. That is, when you have what is called discontinuity. Discontinuity means a sharp increase or sharp decrease or sudden change in the intensity value. That's why we say abrupt changes in the intensity value, and then similarity. That is, you have in that image those regions that are similar in nature. So what can we use discontinuity to detect? Number one, we can use it to detect point. We can use it to detect line or edges. And then these are some of the segmentation approaches. It can be thresholding technique. It can be line, point or line detection, or it can be edge-based segmentation. And mostly the output of thresholding majorly, except when you do multi-level thresholding. But the output of thresholding is always binary, and then binary. So this technique is useful when you have an image that has a solid object and the background on a uniform contrasting background. So these are some of the mathematics associated with segmentation. We have the union rule, and we have the intersection rule, and two other rules. So main method of region segmentation, that is, if you want to do region segmentation, region now, how do you go about it? You can use any of these three methods: region growing, clustering, or split and merge. So region growing starts with one pixel and you grow it of a potential region and try to grow it by adding adjacent pixel till the pixel being compared are too dissimilar. E.g. now, when you want to grow, when you want to use this approach, you take a pixel and you now add more. For every one you had, you will now find out that, okay, can you join this adjacent pixel? Can you join what you have there? If you say no, you will move it to another cluster. So that's how that one works. And then we have the clustering. We are still going to talk about this. I'm just giving us basic introduction. Clustering techniques, and these are some of the clustering. K means algorithm, K means clustering, and its variants, ISO data clustering, histogram, and graph theoretic clustering. K-means is that K-mean is a type of unsupervised algorithm, unsupervised. You don't need training data. It just divides, it just clusters the images into necessary clusters. So this is an example of K-means algorithm. You can see on the board now, what you can see on the board in that image, you can see the areas with leaves or green leaves there. In that clustered image or in that segmented image, you can see all those areas in blue. You can see the building having another cluster there, having another color. So this is the type that we call image clustering. And then this is another one. You can see anywhere you have elements of water here appearing in the other image as green. Or in this case, it's not looking at the water, it's looking at the color. Because when you look at the edge of that house also, that has the color, that has water color, you can see it appearing in the clustered image as green. So that's what clustering is all about. This is another one. You can cluster into multi-classes. That's what I want us to know. You can do more than binary clustering. You can do more than binary clustering. So, and also for lines and arc, you can also use it to recognize object or do what is called document analysis and pattern matching. So, lastly, you can also do edge detection. Now, look at, if you are seeing the board, you have 82 here as the intensity value. You can see it. The aptop change from 82 dropping to 33. That is what you call discontinuity. Discontinuity from 82 to 83. But look at 81 and 82. You can see that between 81 and 82, the difference is not too much. Too much. So the difference is not so much. So we cannot call that one discontinuity. But look at it from 82 to 33. That is what you call abstract change. That's what you call discontinuity in the neighborhood or in the intensity value. That's what edge detection is all about. And then we also have differential operator. You can also use that one to also determine your edges. And then the differential operator is just what you have learned in your bachelor and the rest, or in your secondary school, dy dx, change in vertical over change in horizontal. And the last one, threshold the gradient to select the edge itself. So that is just brief introduction now. But the main issue which I want us to look at is now here. Just a minute, which is going to form our assignment tonight. Hello, are you with me? Let me know if you are with me now. Okay,
Yes,
fine.
sir, we are with you, sir.
So summarily, what we have discussed tonight has to do with how do we segment image. So in your literature review now, this is now what I want from you. Instead of artificial neural network, we just say artificial intelligence. Okay, thank you. So we have about 5 methods here on the board right now. Let me also, okay, religion-based use histogram and rest. Okay, histogram. Let's just add this one. Okay. For some of us that are working on machine vision, don't forget in the previous submission, we have something of this nature. We have something of this nature. Let's look at number 1 to 5 in this paper now that we are having there. You can see that under segmentation, segment an image into useful region or not. Okay. So in the first paper, which is reference 1, segment an image into useful region, yes or no? Yes. So we now want you to now probe further what type of segmentation technique are being used in that paper. So what I'm now asking that you need to create another table now. That table just focus on what is called the type of segmentation technique used in the paper. So, so these are some of the find out, like now, so you can represent this one by TBS. So let's assume you want to represent this one by EBX. And then this one should be what? Anybody? RBX.
Sir, we can't see what you are doing, sir.
Oops. We have this 6 segmentation technique. Threshold-based segmentation, I've mentioned it. I've also mentioned edge-based segmentation. I've mentioned region-based segmentation. Now, clustering-based, what acronym do you think we can give to it? We can use CBX. This one, we can use AIBX. This one, we can use HBX. So what I'm now trying to do is asking you that in those papers that use segmentation technique, go and find out what type of segmentation techniques the author have used. So on the vertical, like for each column, you picked, okay, this one will not be TBX, EBX, pro column will be RBX, CBX, AIBX, HBX. So this first one can be reference. That is reference number 1. That is reference number 1. When you look at this work, reference number 1 that says here, use segmentation technique. What type of segmentation has he used? Maybe this is reference 1 now. What type of segmentation technique the author or the authors have used? Is this TBS? If it is TBS, if it is not TBS, you say no. If it is TBS, you say yes. If it's not this, so you look and classify what type of segmentation technique the author have used for that work. You may come across additional segmentation technique that is not there. You can add it to it. So that what we are now looking at is what type of segmentation technique have been used by the author. So, are you with me?
Yes, sir.
Let's now look at number in what Dr. Fadeyibi, we have finished the other meeting. We are in another meeting now. Yeah, it's just that we are using that same login, Google Meet. So let's now look at paper number 4 here now. Paper number 4, that was this paper number 4.
Okay, sir, I'm with you, sir.
Okay, this paper number 4. And this person to the reviewer said the author did not use any segmentation technique. So it means you don't have to include that paper in your table. So the paper you will include in your table now will be those papers that you have reviewed and you said the author used segmentation technique. If the author have not used segmentation technique, you don't have to include the author in your next in this review that we want to do. So let me allow you to confirm that you understand what I want from you. So please, you can mention it, or you can re-explain or seek for clarification. So what we want to do, those papers that you have reviewed, you are not expected to go and look for another paper. Those 20 papers that you have submitted this present assignment, that you have undertaken the first assignment on, those are the papers we expect you to use again this time around. But now we are zooming down on the classification, on the segmentation approach used in the paper. You must be able to talk to us what type of segmentation, and in order to do that, you need to prepare that other table, and the table is just like this. It's just what I'm now showing you. Which is what we have on the screen now. When you check your screen now, you will see the segmentation technique. So you have to go and prepare a table on the type of segmentation technique used in that paper. So the floor is now open for question and answer. Question and answer, please. Hope you understand what I've asked you to do. Abdullahi Asimiyu, please, can you explain or hope you get what I've asked you to do?
Yes, sir.
Biliki, any comment on that?
No, sir. I understand everything, sir.
Okay. So for tonight, we are just going to look at segmentation. So this assignment and the previous assignment, they are due on Wednesday night. We meet again by 9 p.m. on Wednesday. Okay, 9 p.m. on Wednesday may not be visible because some of you will be traveling. Okay, let's still leave it as 9 p.m. on Wednesday. So you are expected to have you must complete the previous one, then you must also complete. So by tomorrow, you are expected to submit this other table, the assignment 2, the second assignment. And by Wednesday, this one is due for submission. Now we are talking about methodology, but for us to understand methodology, we need to have an overview of what is it all about. So tonight, I've just introduced us to segmentation technique in machine vision. Okay, Abdullahi Oyedokun, your question. This is only for those who are working on machine vision based project. If your work is not on machine vision based, then you need to discuss again, and I will explain it better what your own work, what you are expected to do. Thank you. So, Oyedo, over to you, please.
Okay, thank you very much, sir, for that wonderful lecture, sir. All protocol duly observed, but actually, what I wanted to ask is what you just addressed now, that what of those that we actually were not using for declaration, but I think I understand that, sir, now.
Yeah, but for some of us that are not using or implementing or working on anything that has to do with machine vision, I've explained what you are to do, or because during our meeting today, I observed that those who are not on machine vision, they are still lagging behind. So I've explained what are those things to be done to Larry, and if you are in that category, you should discuss with him or with Fatima. If you are working on leakage prediction, your own table will be what type of prediction techniques have been used in that paper. That's what I'm expecting. And if you are not even using prediction, which if yours is detection, then what you are expected to be looking at has to do with what type of detection algorithm are being used. So I've explained to Fatima, and I've also explained to Damilari for those who are not on machine vision work. So tomorrow, which is Tuesday, 9 p.m., I will be creating time to also interact with us by 9 p.m. and my focus will be those who are working on on artificial intelligence, those who are doing prediction. Thank you. So Oyedoku, hope I've answered your question now. Or Damilari, hope I've answered your question now. So please, any other question? So any question from anybody? So
Yes,
if we
sir.
don't have, yeah, go on.
Yes, sir. One of the paper I downloaded, I saw
Okay.
segmentation based on skeleton.
Skeletalization.
Yes. Is
So
it?
you can, yes, as
Okay.
I've said, the list I have here is not exhaustive.
Okay.
So you
Alright.
can add it you can add it to hit and confirm if other authors also use that.
Okay, sir. All right, sir.
Thank you. So any other question?
No, sir.
Okay, thank you all and God bless you all. So we meet again tomorrow night, 9 p.m. And don't forget the program tomorrow's program by 10 a.m. I will expect all of us to have been at the venue latest 9:30. Those who are having roles to play should be at the venue latest 9:15, if not 9 o'clock. Thank you all. Bye for now.